The extreme value theorem is an existence theorem, and we are going to basically say that something exists based on a certain set of criteria, or in this case, one criteria that we have to meet. The other two existence theorems, you have seen them before, is the intermediate value theorem. You can see me waving my hands like you did in the other video. It's the intermediate value theorem and the mean value theorem. So here we go. I'm looking for extreme values. We're going to call them extrema. It's a Latin word that means extreme. All right, given the graph of the function on the right, state the coordinate x and y value of the maximum and the minimum on the interval. And we're going to go from 1 to 2, including 1 and 2. This one is a closed interval, open interval, and I'm going to invent some words. This one is closed at first and open on the end, so this is a clopen interval, and this one is open then closed, so it's osed. Yeah, clopen and osed. You will not see that on the exam, so let's not even play that game. I want to go from 1 to 2, and if I'm going to go from 1 to 2, then I am going, well, from 1 to 2, and I want to know the lowest and the highest, and I think it's going to be fairly obvious. So let's make a little chart here. I think it'll just organize our thoughts a little better. So we're going to have a maximum, we're going to have a minimum, and we are going to list them as coordinates, and we'll just do that for all of these all the way down. So the maximum on the interval from 1 to 2, I'm going to take this little piece of paper that you can't see off camera, and I'm going to rip it in half. There you go. And we are going to find the highest and the lowest. Whoop, paper got bumped. There it is. We're going to find the highest, and we're going to find the lowest. And the highest is at 2 comma something, and the lowest is at 1 comma something. And I think it's fairly straightforward at this point. So the maximum is at 2 comma, now let's not confuse what's about to happen. That's an interval. This is a coordinate. So we're going to have a lot of things that look alike that represent very different things. 2 comma, I'm going to say 29. Yeah, that looks like it's halfway between 28 and 30. So 2 comma 29. And the minimum is at 1 comma 18. Okay, not so bad. Let's go from 1 to 5. So the highest value from 1 to 5 and the lowest value from 1 to 5. And notice that we are dealing with 1 and 5. It is a closed interval, so we do include 1 and we do include 5. So the highest value is that one, and the lowest value is that one. And we're going to really take this idea and kind of run with it in just a minute and talk about what the extreme value theorem is and how we come up with these things. But notice, let's go ahead and start that conversation. Notice that in the first instance, the highest value was at the end point of an interval and the lowest value was at the end point of an interval. And now notice that the highest value is where we level off at the top, like it's a peak. We'll have words for that in a minute. And if you want to get all derivative-y about it, it's where the derivative, if you drew a tangent line, it would be horizontal, so the slope would be 0. And the lowest is the endpoint of an interval. So I'm going to jump ahead of myself a little bit here. You have the potential to have maximums and minimums at endpoints of an interval or where a derivative is equal to 0. There's one more place where that can occur. In the meantime, let's find the maximum, which is at 2 comma 29, and minimum, which is at 5 comma 2. All right. So max is 229. Again, this is a coordinate, not an interval. And 5 comma 2. And I want to back up and say something again that I just said. In our very first example, when we were going from 1 to 2, our maximum occurred at the endpoint of an interval, but it is also where the derivative equals 0. So sometimes there's a little overlap in what we can be looking for. So if I'm not making sense yet, don't worry. I'm saying a lot of things out of context now, but in a minute they will make sense. Okay, from 1 to 5, I can include 1, I cannot include 5, and I'll definitely include everything in between. So highest and lowest from 1, yes 1, to no not 5. So this is a open then closed interval. No, sorry, closed and open, so it's clopen. Highest value is there. There's our maximum. I think that's going to be pretty straightforward. Let's go ahead and put it. And you're like, man, that is the maximum all the time. Well, for the first 3 at least, maybe more. And the lowest value, I would love to say that it is here, but we can't count that. So you might want to say, well, then maybe it's the one that's right beside that. Well, then what's right beside 5? Oh, 4. No. What's right beside 5? 4.9, 4.99, 4.999, 4.9999. You can list 9s all day, and you're never going to get a point so close to 5 that it is truly the minimum. This is technically an open circle right now because of that parenthesis, so there is no minimum. All right, here we go. From 1 to 5, not including 1 and not including 5, I think we've already figured out that in this situation, since we can't include 5, we don't have a minimum, but we actually still have a maximum. This point is still included. So no, can't include that, and that's where our minimum would have been, but I can include that. It's everything in between. So 229 again, and none again. Same answer as the last one. Now let's go from 2 to 5. I cannot include 2. I can include 5. Keep bumping my paper here. I cannot include 2. I can include 5. So what is the highest point? I'd love to say it's this, but I'm not allowed to count that. So there is no highest point. There's none. So finally, we broke the streak of having the same maximum. The minimum is at 5, 2. And I don't know if you noticed, but it just got brighter. The sun came out. I'm sitting beside the window right now. See? There we go. Mr. Sunbeam is here. And then we're going to go from 2 to 5. Yes 2, no 5. So we will, yes, count the 2. No, don't count the 5. So 229 and no minimum. 229 and none here. Okay, we have a few little things to deal with as we proceed in this video. The extreme value theorem, again, it's an existence theorem, and we have to meet one criteria, just one, that's it. It's the only one we have to meet, and let's write it. Let's write it in, pick a color. Blue, glad you picked blue, that's what I picked up. If f, the function f, call it f of x if you like, is continuous. Let's just stop right there. And we're going to keep writing in a minute. But if f is continuous, that is the condition. That is the only condition. Apparently, I just wanted to keep underlining. I don't know. If it's continuous on a closed interval from A to B, and I'm going to actually continue the underline here because that is the condition. All we have to have is continuity. That's it. Other things that we've dealt with, intermediate value theorem had to have continuity in betweenness, and the mean value theorem had to have continuity and differentiability. There's some different things. This one is just continuity, that's it. Then the function f has both a maximum, abbreviate that if you like, just call it max, and a minimum on the interval. Okay, and it makes sense, all right? So I'm going to take this paper that I had ripped just a second ago. If I have a function that is continuous, then I'm going to have a maximum and I'm going to have a minimum. And it has to be continuous on a closed interval, otherwise we run into these situations where it's not a closed interval and we don't have minimums or we don't have maximums, things like that, okay? But if I was to just draw any function, and don't lift my pencil, there we go, I'm going to have a maximum and I'm going to have a minimum. There's my max, there's my min. It's going to happen. You can draw it like that if you like. I'm going to have a maximum, I'm going to have a minimum. It's going to happen. There's no way to escape it. You just can't. So we'll talk specifically about where those points occur, where those maximums and minimums occur, although we've talked about it just a little bit already when we said they can occur at the endpoints of an interval or where the derivative equals 0. Again, there's a third one. Let's do a little bit of vocabulary, and that would be where we talk about extrema. What's an extrema? Let's keep going with blue. It is a maximum or a minimum. That's just all it is. Let's not make that harder than it is. A relative extrema is any high or low value. So without wording it exactly like that, I'm just going to point to it. There's one, there's one, there's one. Any high value or low value. And the technical definition that I guess I could write down is the highest or lowest in a smaller interval. So this is a maximum just within its own little region. You can call them peaks and valleys. There's a mountaintop, there's a mountaintop, there's a lower valley. There it is. Absolute extrema are the highest and the lowest. What about that one? It is not the absolute highest. It's not. This is the lowest. This is the highest. This is a maximum. It is not the maximum. And there's the difference.